This is Joel Trudeau. He's a professor at Dawson College in Montreal. He's going to talk to us about painting by numbers with Arduinos today. Take it away, Joel.
Thank you, Sarah. Hi, everybody. Quick show of hands, if we can do that. How many of you have been exposed to Arduino before? How many of you have no exposure to Arduino? Let's see if we can see it. Okay, great. Well, I'm going to assume that we're all a bunch of 7-year-olds. And we're 7-year-olds who are very curious and excited about the world of Arduino, and we don't know it yet. And we're going to discover, hopefully together, that initial curiosity, that childlike curiosity, can be taken into learning Arduino at earlier ages and can carry through all the way to very advanced projects. I'm hoping to make that argument today. So I'm going to share my screen. I'm just going to do a few slides and try to situate this a little bit, give you a sense of my background and what I've been doing here in Montreal. And then I'm going to take you on a virtual tour of some of the things I've been working on over here. It'd be great if we were in person, because then we could get on the hardware, but we're actually going to get on some virtual hardware. So let's see how this goes. Share screen. Can you all see my screen? Got my slides up here. No, there's not 42 slides. There's just a few. So again, my name is Joel Trudeau. I teach in the physics department here at Dawson College. Lately, I have not been teaching a lot. I've been doing outside the classroom teaching a lot and working with teachers in co-curricular settings. We're thinking about new programs here. We launched a new makerspace pre-COVID, and that's got off and running, and we've got many big projects going on here. But one of the things that I do across programs outside of the physics department is I coordinate an initiative called SPACE, which is an acronym for Sciences Participating with Arts and Culture and Education. It's essentially a STEAM initiative, but we don't tag ourselves only as STEAM. We think of ourselves as being an antidote to streaming in programs at an age when students still don't know what they want to be and what they want to do. We want to expose students to as many things as possible. I also have a small consultancy where I'm trying to see how I can maybe better spread these ideas outside of my own institution with partners. But I wanted to just start this with a little story. Have you ever seen those the 5 levels wired series where it's explainers, explainers to a kid, explainers to a teenager, explainers to a high schooler, an adult, an expert, and so on. So this is Sean Carroll, you may not know, explaining about black holes and cosmology. You can start with a 5-year-old, and you can go all the way up to experts. And I think as educators, this is an interesting thing to think about, and I'm inspired by this. So when we really master subject matter, we should be able to explain it to our kids. And I myself have a 7-year-old son, and he's precocious and he gets a lot of attention at home. But he's a normal kid, and I think all kids have innate potential if it's nurtured. And so I really feel like making is that vehicle for nurturing our kids. And so I've been playing with LEDs as a way of looking at this problem of, how you can introduce elementary electronics and programming concepts to younger kids, and kind of short circuit the problem of learning a programming language. So what I'm going to present to you today is something like visual programming. I'm just calling paint by numbers because we all kind of get that from when we're kids, or things we might have done with school-age children, and see how that translates actually into a coding environment. So as a place to start, where we sort of embrace our creativity, and then see how we can, bring that creativity into a technical problem. And So I've been testing this with students at the college level, but also with first graders, also with underserved communities in the 12 to 14 year old range. Myself, I have a Indigenous background. I'm Anishinaabe Ojibwe, and I've worked with Indigenous students here at the college, and we're thinking of various activities that we can do together that have a cultural dimension, as well as can teach STEM and STEAM skills. And I'm quite inspired actually by the students that I work with here. And in some ways, I'm following their lead. And I think that's a message that I'd like to bring as well, that we can learn a lot as educators by making with our students. And I think it's important to recognize making in public ways. So I also am a firm believer in providing venues for the students. So the making should come out of the closet, out of the makerspace, and into some venue. So every year we have kind of an exhibition of projects. And you can see the top right here is sort of an interactive LED version of what I'm going to show you today, where people were doing kind of a paint by numbers on the spot design of their own icons. And hearts seem to feature all the time, which I like. Okay, so just a quick overview and then we'll get into it. So I'm going to skip over the making with Arduino bit because I think most of you have been exposed. And so I think to be able to maybe play with some of these activities would be better use of our time, and to leave enough room for discussion to see, if there are other avenues that we might be able to innovate with this approach. So two basic activities. We're going to start with this idea of just jumping right in and programming with Arduino. So we're going to use Blink, and we're going to use Blink in a virtual environment. I want you to get used to the platform we're going to work on. And then we're going to go and design, I don't know how well that's showing. We're going to design our own icons. Here's my turtle. That's my turtle. And what I hope you'll be able to do is share with me your designs on the fly, and I'll upload them into the hardware, and we can share that way. So I'm going to skip over the Arduino bits and just kind of jump right into it. And just sort of reiterate that you can start very simple, and you can also scale to something more advanced. So with the same kinds of concepts, technologies, libraries, should probably turn down the volume there. You can scale out to a larger display, right? These are essentially low resolution screens. So this is an example of a project that several advanced students did that was part of a larger community project, which looked at this notion of trying to go beyond the speed of light. And one of the interesting, at least for me, metaphors, analogies, interpretations of what it means to go beyond the speed of light was this sense of community, how we transcend our own limits when we work and collaborate with others. And that's kind of the ethos I want to bring into project work with students and with collaborators. But this is all with LEDs. So what I'm going to do now is I'm going to share a link. I'll stop share for a second, and I'll put a link in the chat, and then I'll kind of walk us through it. And maybe Sarah, you can give me the thumbs up if that's working, please.
Yes,
Great.
all good.
Okay, so now I'm going to get there. I'll share screen again. I'm going to walk us through it, and we're going to play. So this is a little bit rough, but it's meant to be interactive in this environment. Normally, I would want to expand things out a bit, explain, give time for a lot of feedback, but I kind of just want to introduce you to the idea of collaborating virtually and then physically. There's an important reason for this outside of it being an entry point to Arduino for multiple ages and backgrounds. I think also making use of virtual technologies will allow us to decouple some of the learning of the programming skills from the engineering and making side, develop those skills kind of in parallel, and then you can bring them back together. So I'm kind of excited about the new technologies that are being developed. So if you go over to blinking LED, the reason I'm using this one is because this is the default program that you get with a new Arduino. You power it on. If it's working, your LED blinks. In this case, I've also attached to our Arduino, if you can, don't know if you can see the built-in Arduino blinking or not. You know what I'll do? I think I will move those screens out of the way. I'll stop. Yes. Okay. Try then. I gave you the answer. Okay, so you can see the LED, the built-in LED blinking, and the first time you power on your Arduino, this is what you're going to see. And so it's a way of testing whether or not your hardware works. It's also, when you look at the underlying sketch or the program, the Arduino program, you can immediately see the skeleton for all Arduino programs. So I've got some boilerplate code in here, but the two aspects are the setup and the loop. And what we're doing is we're loading that default blink program. And down here we have a serial monitor in case there's errors. This is working, so I'm just going to close that. What we'd like to do is not look at the code or not get too much into the understanding or getting bogged down in the functions that are there. These are all commonly used functions. They're semantically interesting and they are part of Arduino out of the box. What we'd like to do is just think programmatically to start and use some simple reasoning. So first exercise, modify the code above to make the built-in LED blink on and off for 3 seconds. So let's have a look at what's going on here. The loop function, once it's initiated, will loop forever as long as the Arduino is powered. And we've got some comments in here. So what's happening? We want to turn the LED to turn on the LED to begin the loop, wait for 1 second using a delay in milliseconds. So that's 1000 milliseconds or 1 second. Then we'd like to do what? Turn off the LED, delay again, so that the off state is there for 1 second, and then loop. And so what you have is alternating between on, off for the built-in LED. The built-in LED, if we wanted to examine this more closely, is set as an output pin. But for us at this moment, that's not important. What's important is we want to get the thing to blink, and this is how it works. So just to get familiar with the simulation environment, what I'd like you to try to do is make it blink on and off for 3 seconds. Take a minute. Can I get a thumbs up if somebody got it to blink on and off for 3 seconds? Great. Okay, so let's just show the answer for that. Simple modification. Change the delay to alternate off and on every 3 seconds. And so it's blinking slower. See it there. Okay. So let's just go a little bit beyond that, and then we'll look ahead beyond blink. So there's another LED connected to the Arduino board, and in the environment that we have, it's a red LED connected on pin 11. And you'd like to be able to do is modify the code to make the red LED and the built-in LED blink alternately. You can have them blink together. So what we'd like to do, for example, is look at in 11 as output, so I could get you started, and then do something in the loop, right? So instead of the built-in LED, you want to get the wired up LED with this resistor to blink. So take a minute to try and figure that out. I'm going to try to run this. And you'll see what happens is that I get an error. So this is very much like your output, your console log, error log in the IDE, the Arduino IDE. So we'd like to give it a state of either high or low. Let's say it's high. Low. What's happening is that they blink together. Now, if you want them to blink alternately, what do you think you have to do? Anybody? Feel free to unmute yourself if anybody wants to chime in.
Do we switch the high and the low for the 11 one?
Exactly. Great. All right.
I actually have no idea what I'm doing. So I am the 7-year-old in for this point.
But that's exactly right. It's intuitive, right? So once you see the example, understanding is slowly built, right? About how you manipulate these pin modes, but it's not necessary for what we're going to do. This was to introduce you to the simulation environment, so you're comfortable with how to get it to run and what is typically loaded into an Arduino to start. Okay, so we're essentially going to modify blink and play with LEDs and scale up the complexity. So the answer is here. If you want to try that, you can copy that in. But we want to think sort of beyond this, right? So if you were thinking about how you might complicate this kind of exercise, right? What's interesting about it is that it will introduce elementary programming and electronics concepts very simply, just with the default sort of out of the box sketch and hardware. But what you might do then is also explore electronics as in, you know, the circuit design involved with adding this extra LED and the resistor that it's attached to. And then ask yourself, why is this resistor used in the circuit, right? A discussion could be generated around that, but also you could look at the electronics. It depends on the age level and the background. You could also explore real world applications. For example, adding more LEDs, creating a traffic scenario or traffic light controller, multiple traffic lights, right? Where now you've understood how to blink one LED, so you've understood how to blink many. You just need more pins. And the idea would be, you know, that you could start to think about simulating real world behavior. You could also take this a little further with LEDs, simple single LEDs, design a game. For example, adding push buttons, you could design a game of Simple Simon. So what we'd like to be able to do is say, can we do with this starting point? And what can we build and scaffold out of that to more and more complex concepts and activities as the learner progresses? It's also, fun to see how far you can push this. Okay, so let's start with our paint by numbers example. So we have a little bit of experience with the virtual environment now, and we want to introduce the LED matrix display activities. And so it's got a basic wiring setup. I have one, again, I have one here where you can use a dot matrix, which is essentially on and off. And what we're going to do is we're going to use ones and zeros, like on and off, and program rows and columns here based on a paper design. And what I'd like to be able to do is translate that over into something that's a little more complex, but we'll read in the same bitmap so that we can then add colors after. And this is what we're going to simulate in the virtual environment. But the design will be exactly the same. How it's implemented is just slightly different. But for our purposes, the core design activity in translation to bytes or ones and zeros, it doesn't depend on the hardware here. Okay, so here's our warm-up problem. Turn that frown upside down. You've got a grid of ones and zeros, and you'll just notice the B's out front because these are bytes, and they're spaced out so you can see, actually visually see, that these ones make a frowny face. What we'd like to do is take out the frown and replace it with a smile. So how do you think you would do that? Well, some ones you'd have to change to zeros, and some zeros you might have to change to ones. So why don't we give it a try? So if you did that on paper, right, you could look and see that row 5, 6, and 7 are probably the most obvious to change. So why don't you give that a try, and then we'll see. We'll see how it goes. So if I were to simulate what it looks like right now, there's our frowny face. Okay, so let's have a look. If I did this right, should have a smile. Maybe I have an error. Just gonna follow the model here. Not a very nice smile. I should move everything up one more row. But the idea is that you can see immediately that just by changing digits, right? And if you were to do this on paper, and I'm going to give you a paper schematic in a second. If you're to do this on paper, you could see very clearly that you'll be able to draw that out and see the design before you even get it in code. So let's have a look at that. So let's make our own design. So at this link, if you follow this link, and I can also, I guess, put the link in the chat as well, make it easier for you. This link. You'll find a schematic. I don't imagine you all have printers right now, but this, you can draw on a piece of paper, a simple 8x8 grid, and then follow the instructions. And the idea would be that so if you take a pencil or pen, one color, and just color in each of these squares, if you colored all of them in, they'd all be ones. Okay, and so you want to design a character such that you have ones and zeros representing the squares that you've colored in or not colored in. So let's take a few minutes to do that. So, for example, the turtle, if I take that, put that back in here. So if somebody's made a design that they'd like to share, you could upload that into the chat. And I think what I'd like to do is loop multiple designs that folks have come up with and show you how you can do that. Who's got one? Is it Reagan? So the only thing that's missing are the B's out front, but we can use that. So let's try it. There you go. X marks the spot. Let's look at the chat. We also have. Wonderful. Robot, creature from wavy hands, creature from outer space. That's great. Okay, so this just to show you the basic introduction, right? So it's fairly straightforward to get kids drawing on paper and then thinking about what those squares represent in terms of a simple on-off question. So you've got this light that goes on and off. Oh, and that's a 1 or a 0, right? And so you can start to teach them elementary computational thinking skills, as well as, create something interesting. And then when it comes to life, they're always quite excited by that. So what would be interesting is to take that a step further. And so what I thought that we could do in the remaining time is to think about making things just slightly more complicated, but not that much more complicated. And thinking about more colors. Let's take advantage of the fact that we have hardware here that's not only on off, but can be a combination of RGB, right? So that you can specify colors. And what we're going to use is a spreadsheet tool that you can access at the link here that I've adapted from Arduino++ work. Let me see. So awkward sharing in the chat while you're sharing screen, but that should do it. And so if you go in the spreadsheet tool, you can see visually right away, right? And this is what I wanted to do. Wouldn't have worked as well on paper unless we were sort of all together and we could see each other's designs. And so rather than program using language, we're going to program using ones and zeros in a boilerplate spreadsheet. So this is a Google sheet, but you could also export that to Excel, no problem. And what you'll see here is you've got a legend of colors. And here you have a grid. And because it's possible to also do 16 by 16, I thought I would leave it up there. But we're just going to do 8 by 8s. But what you notice is that when you change a number here, that there's a grid of values over here that just get mapped as their Excel functions into this table of rows. Now, each one of these rows represents essentially the bitmap or the byte or this, the string of colors along each row.
Oh, Joel, I'm so sorry. We are out of time. We have 1 minute. I've been playing around and not been a very good host.
I wasn't following the time. So we have 1 minute.
Yeah, we're supposed to pop back in about a minute.
Okay. So in the remaining time,
for questions.
in the remaining time, I would say you have the link. Go and check out the activities that were linked there. Play around with it, and feel free to stay in touch with me.
I have a quick
if
question.
You want to find out more. Yeah.
How did have you worked with? I mean, I'm looking at a camp for 8 and 9-year-olds next summer, and thinking about doing something along these lines. Part of why I jumped in, because I do an older camp with Arduinos with older kids, and it's a lot easier for me to figure out what to get them to do. But I kind of wanted to introduce the younger ones to Arduino. Do you think it's good enough to introduce it and have them do it simulated, or should we be having some hardware on hand? I just can't see using the hardware with the younger students because of dexterity, and I've tried to do the camp with younger kids with the older camp. Now I'm trying to change it to a different camp for the younger kids because they just couldn't do it on the more advanced stuff with the hands-on and
I'd say you could do a mix.
Day-to-day learning too is another thing I find. They don't remember with programming from day to day, and we do some pretty extensive programming in the other one. So I was wondering what your experience was.
So plug and play is if you're going to use hardware, is recommended.
That's what I do with the older kids.
Right?
But younger kids,
to design activities around that where they can exercise their creative muscle, and that is modifying something that's plug and play. And that's why I think the LEDs are very interesting, because you can start to make simple games with them and so on. You can start to scaffold these ideas with the 8 and 9-year-olds. I would just go for making LED matrix designs and having them augment clothes or put them on their shoes.
Yeah, we have a whole fashion camp that does that kind of thing.
Right. So great. Yeah. So you know that. But the simulation activities, I would suggest, right? Because you're removing a couple of layers of abstraction or complexity.
Complexity, yeah. Okay. Yeah, you got me thinking. I'm now thinking that I've jotted a bunch of notes down of things I want to explore before summer. Yeah. For everybody.
Great.
But thank you.
Stay in touch. Yes,
Will.
my pleasure.
I like your interface too. Just FYI.
Yeah, it's in development, and we're also focused on robotics. So we've got robotic simulations, and
I saw that because that's another whole arm of our possibly having a robotics, not really camp, but a robotics team group, year round kind of group or something at our lab. And we've been trying to figure out how to start that and work towards that. So.
I have a
so
question
here's
for you.
the robotic stuff that we're using. But one of the ways we're thinking about it is build a mission rovers
Mhm.
over a year. And so it becomes a STEAM project, and you can really incorporate robotics.
Yeah, and
as well as
our
yeah.
science center just opened Mars, Mars exhibit. So I've been trying to think about how to tag that into that. So rovers is kind of but designing a mission, that's a great idea. That they might even do that with the younger kids. Sorry, somebody else had a question. I heard.
Yeah, I have a question. So that was 45 minutes for some folks who kind of know what they're doing. And like I said, this is not my area of fab. So thinking of 45 minutes with school age kids, that's normally the chunk of time that we get for them. So starting with this, just the blank, and if we were just going through this without the hardware, just the simulation stuff, how far do you think you could get with a group of, call them 8-year-old, 3rd, 4th graders?
So I would actually start with the drawing. You start with the drawing, and you introduce,
and then go back.
you start with the paper, and you get them to design something. They're always designing characters, right? And you give them the constraint. We're going to draw something, and what's fun about this is that we're going to then put it on a piece of hardware, or we're then going to make it light up, right? And so you start with the thinking that they're used to, and that goes a bit faster, and then you can guide more easily, I think, the transition to ones and zeros.
You can kind of call it a storyboard,
Yeah, exactly. So you storyboard it. So that would be it, especially for the younger kids, that a way to do it in a short amount of time. I might have approached this not knowing who the audience would be exactly in that way if I was going to do it again, just like that. But I wanted to introduce this idea that you can get a range of learners into Arduino, and excited about Arduino, and teach multiple things with the same chunk of hardware.
Well, thank you so much, Joel. I really had fun with this, and I think that the spreadsheet tool was definitely the coolest thing for me that I know I'll definitely be taking away.